Hey guys, so this is going to be the second video for algebra. So as you can see from this list, there is a lot to cover. So that's why this is going to be the first part of two. So you can see in this first list that we're going to go into more complex concepts. So the first one here, Pascal's Triangle, that is predominantly higher level. So if you're at ordinary level, you don't need to worry. A lot of the examples, they're going to be suited for higher level, but with ordinary level students, they will basically just be very hard examples. But even then, you can use a different question, a much easier one, and the concepts will be the same. What I looked at in the first video was predominantly the very basics of algebra and looking at the simple concepts of addition, subtraction, division, and multiplication, the very simple stuff. And this time around, what I'm going to be doing is going more depth into that, except I'm going to be bringing in more concepts and more rules. So we're just going to jump right into it then. You can see here Pascal's Triangle. What Pascal's Triangle is, it's a concept that was made from a binomial expansion, which we will get to. Just know that term for now. What we say is something similar to this. So this is an expression, and if we wanted to expand that, that would be just very long to do. I'm not gonna lie, it would be very long and ugly to just keep going and waste your time. So what Blaise Pascal, a French mathematician, discovered was that when you look at all the expansions in this form, so if we look at a plus b to the 0, a plus b to the 1, a plus b to the 2, and so on in that order, what it shows is that all the coefficients forms a pyramid or a triangle. We use this triangle to represent the coefficient from the expansion. That represents row 1. Now just do that. 1 and 1. This represents a plus b to the power of 1. So you see that the powers of the a and b solely is 1, and the coefficient is going to be 1. So now we want to look at row 3. So now this is where it gets different. So what you do in this case is you take the 2 ones in this row, and this is going to be the sum, the answer that you're going to get in here of these two. So 1 plus 1, well, simply 2. So that means the coefficient of the middle term is going to be 2. The coefficient of the first and last term is going to be 1. Now we just scroll down again, and it goes on. Now it just goes on like this for the remaining terms. So that'll be 1, 3, 3, 1. So now we're gonna do it again. Another tip, the outside terms, so you can see all these ones on the edges, they are going to stay the same. They're always going to be 1, and I will explain in a bit why. So now you can see here it's going to be 4, 6, and 4. Finally, the last one. We're on our last one, guys, don't worry. So now, as I said before, 1, 1, and now it's going to be 5, 10, 10, 5, and 1. So these represent the different rows, and as I said before, the powers will start from 0, and as you go down the triangle, the power will increase by 1. So you start off with a plus b to the 0, a plus b to the 1, to the 2, to the 3, and so on. So now how we look at that is, so we have a plus b to the 0 is 1. So now what we say is a plus b to the 1, that's a to the 1, b to the 1. You can see that the coefficients are 1 because, there's nothing in front of it. And whenever it stands on its own, it basically just means it's 1a. So, yeah. So then you have a plus b squared. So now we're going to write it as a squared plus 2ab plus b squared. So what you need to remember is that this a is going to have power of 1, this b is going to have to the power of 1, but you need to look that numbers you have in the row above other, those powers will be in the middle terms, but every time you'll have to switch them, or actually no, that's wrong. I'll just keep writing them and you'll see now they all differ. So a plus b cubed is going to be cubed plus 3a squared b1 to the 1 plus 3a to 1 plus b to the 2 plus b cubed. And it just keeps getting longer and longer, so I'm just gonna leave it at that. One thing to remember is just this triangle, and it'll keep going down, but you can do the addition yourselves. I've just given you the tools. So have a look at that, and that is basically the form that Pascal's triangle takes. And you can see this, this, and this. Just remember to use your coefficients. Use this rule here that I've written very messily. So when it's a plus b to the 4, you know it's going to be row 5, so it's going to be a4 plus 4a to the 3, b to the 1. I say, hang on, a plus b to the 4 is going to be a to the 4 plus 4a to the 3, b to the 1 plus 6a to the 2, b to the 2 plus 4a to the 1 plus 8 plus 4a to the 1, b to the 3 plus b to the 4, and so on and so on. So factorizing. So there are 3 ways of, or 4 ways even, of factorizing. You could use the highest common factor. So what that means is basically looking at an expression and thinking what is common in both terms, where we can extract that to make a product of two other terms. So just take an example here, x squared minus 3x. So what's common in both? Well, there's an x here, there are 2 x's in here, so there is an x. So the highest common factor is going to be x. You take x out, and what do you have left? Well, you divide both sides by x, so when you divide x squared by x, you're just taking out one of their x's, so it's just x. And when you divide minus 3x by x, you take out the x's, so you're just left with the 3. So that would be your answer. So you have a term inside the brackets, and you have a term outside it, which is a product, and it will go back to this form. So that would be the highest common factor. So grouping is another one. Grouping. What this means is that you're taking one whole expression, and so there will be 4 terms, and 2 of these terms will have a similar variable. The other 2 will have another similar variable. And what you do is you act as if they are 2 separate expressions. So, an example would be a to the x plus bx minus ay plus by. As you can see, you can obviously group it by ax minus ay plus bx plus by, but in this case we're focusing on our x and y. So what you do in this case is you act as if these are 2 separate expressions, then you will regroup them at the end. So now in this case, you'll be using your highest common factor. So we're going to go down. So the first expression, similar in both, is the x term. So we'll take x out, and since both of them have x already, you don't need to draw it again. Minus. The second one, there is a y, so y in both, so you take y out, and because there's already just one y in there, it's not going to be written back again, so simply just that. To make it simpler, how you would express this is you see that a plus b is common in both, so what you can write is a plus b, you can divide them both, a plus b, to just give that. That would be grouping. This one is going to be the difference of 2 squares. So I'm going to write diff of 2 squares. So what you do in this case is that have expression with 2 variables. The variables will be to the power of 2. So x squared minus 5 squared. Okay, these are 2 separate terms, an expression. So we would look at this is that, for a difference of 2 squares to work, coefficients must be higher numbers. I'm going to show you why. First step is getting the square root of both of these, because 4x squared is 25y squared is are 2 terms with same coefficient multiplying together give different coefficient a powered table. And so we're just going to find this out. So say x squared is the same as that minus y. I'm going to scroll down a bit. So you can look at this and say, so minus sign. So don't forget the product rules. Minus gives a plus, plus by plus gives a plus and minus gives a minus. This means, what the squared means is that there's going to be two different expressions. So separate expressions multiplying together. So to write first of all, sorry my pen clicking, 2x minus 5y, one expression. How do you get this minus sign here? Minus by minus is plus, so no. Plus and plus gives plus, so no. By plus gives minus. So there we go. In our second expression, sign is going to be changed. It would be how you get the difference of two squares. You get the square root, each of the coefficients first of all, write it, the bracket, over square root number multiplying by the variable, and have the power outside, which in this case is going to be 2, because it's quadratics, squares even, and you write them as two separate expressions. And depending on the sign, it'd be plus or minus and minus. Is a plus, you'd write is x plus 5y, leave it at that, right, or, in bracket, 2x minus 5y, closing bracket, or 2. I mean the same thing. And one is like trinomials. I'm gonna write quadratic trinomials. Okay. So this is basically an expression where you have three terms in one expression where each term decreases by power in its variable. So this one is going to be squared. One is going to be to the power of 1. The third number is going to be a constant because it's going to basically represent, let's just say, x squared 13x plus 15. What this 15 represents here is just draw to the 0. As I already said, anything to the 0 is 1, so bye. And how you would do this is basically, actually, this is simpler. I'm going to get rid of the 2, write 10, no, I'm going to write 7, 10. 12, use the 2 because in a minute what you can do. Okay, so what you can do is, if you're really good at maths just in your head, you can just look at this and say, okay, look at the products of 15. What two numbers can you make get to 13? Well, just looking at it, none of them. But anyway, you can use the 2 and have the products add up to 13. Yes, you can. Write it as so, x bracket, bracket, x, closing bracket. There we go. So, case, what we will be using is 3 and 5. Simply because the other one would be 1 and 15. Multiplying either of them by 2 will not work. So, what we are going to say is 3 and 5. But which one are we going to, well, they're both plus. So, here we go. Now, where do we put each number? Well, you can try multiplying the 2 by 3. So, let's write this. 3 and 5. Let's start by writing that. Well, you have 2x multiplied by the x to give 2x squared. 2x by 3, that's 6x. 5 and x is 5x. 5 and 3 is 15. And okay, you add the 6x and the 5x, that's going to give 11x, okay? Oh, not okay. That's 13x, not 11x, so that's wrong. So, in conclusion, we are going to swap the numbers. So it's going to be 3 and 5. And now that works. 2x by x is 2x squared. 2x by 5 is 10x. 3 by x is 3x. 3 and 5 is 15. So that answer that we want. Now we go on to the sum and difference of two cubes. So we looked at squares, and now we want to look at cubes. So we're gonna, so a cubed plus cubed. Okay, so kind of a simple one to expand, because what you can actually do is you can see, okay, what is common in this, and that you can take out an A, which will leave literally the same thing. So now we already know how to expand a quadratic. Pascal's triangle, you can see that it is that basically. So that would be how you do that. I just want to say one more thing about factorizing. You can the square rule if you use doing this. See if I'm actually going to be doing it. It will be in the second part of the video. Never mind. Okay. So a look at that. So that's fairly simple. I might do an example. So let's look at a cubed plus 27b cubed. Okay, so what is common in both that you can take out? Well, another thing you can actually do is find the cubic root. So if you take out your calculator, try and have Casio X83 GT Plus, one that they love with the leaving cert. So try get that. And what you're going to be doing is, see here there is a square root button, shift, and that button, and that gives the cubic root, and type in the coefficient of A. So we're going to have 8, 2. We're going to do is 2, plus the same for 27, it's 3. You basically just divide each of them by these. You have here 4A plus 9B squared. And when we look at it closer, B plus 3B, and go back up, actually can write that, and this and this, and basically be your square root of the coefficient. I'm confusing you now. Okay, so I'm going to go back to this example. So we have squared and squared. If you remember the difference of two squares, that's what we're going to be doing. 2A plus 3B. You don't need to write anything else, that is it. We're going to go on to algebraic fractions multiplication. I did the fractions by didn't go through that, then I'm just going to say it really quickly. So x plus all over d x plus g equal to the common denominator d all over d all over g x plus b d. Stupid drawing. Free pen. Where'd it go? There we go. Let me see if I can still draw it. Okay. My god, draw the x f. That annoys me so much. So that would be by addition. So you get the lowest common denominator between d and g, and get your two expressions for the numerators, and individually you multiply it by the lowest common denominator divided by the opposite term for the opposite denominator. Okay, to ignore that. So he's all got that. So now we're going to do it by multiplication. So have a numerator. When you have a fraction multiplying by another fraction, what you do is you take your numerator and you multiply the numerators together and you multiply the denominators together. Algebra, it is different. But what you do instead is try to simplify them before you as one fraction. So let's take an example here. X squared 27 all over x squared minus 15x 9 divided by x minus 3 all over squared plus 3x. So now you have a look at that and you see if you can simplify it or factorize it. So steps you always remember. Number 1, simplify. So simplifying, you can't really simplify any of them off the top of your head. But can't simplify any of them. So what you do next is factorize. And so say 27. 3 was common in both of them. And in the bottom, in the denominator, we can do that. So now it's going to be x minus 3. It actually isn't. Minus 3 to get that. Minus 3 you can't. Right? One you can. X plus. So now you can write this as one fraction. So factorize the term in the brackets. So the x squared minus 27 fraction. You can say, my bad, it's x minus 9 actually. Difference of two squares. Multiplying all that by 4x minus 3. You have your denominators, x minus 3 plus 3. Actually, look at this. The terms are going to cancel out. So we have a 4x minus 3 and a 4x minus 3. That can go. We have an x minus 3 and an x minus 3, an x plus 3 and an x plus 3. Now you write this. So it was, I tried to see if I could simplify it. I couldn't. So I tried to see if I could factorize them individually. Denominator individually, each numerator individually. And I could, so I did. And I just merged them together by numerator and denominator by denominator. And I saw if I could cancel anything out. And if I could, I did. If I couldn't have, then I would have just left it as it was, because there's no need to keep going. Okay, I'm going to go into complex fractions. Now these would be, okay, so let's just give an example here. Say it numerically. You would say plus a third over 5 plus 3 over 7. You do here, so I would try and do first is the 1 and the 1 over 3 as, so the what's 1 whole, so it's going to be 3 thirds, that's 1 third all over 5 plus over. See here, that's going to be 4 over 3 over. Now for the next one, you're going to have to get your lowest common denominator. So what's it going to be? 5, 10, 15, 20, 25, 30, 35, 40. And in the 7, 14, 21, 35, 42, 49. So which ones were similar? It was 35. So 35 is going to be the greater. So 37 divided by actually 7. So 7 by 2, which is 14, plus by 3 be so it's going to be 29. Just like that. I'm going to go back to here. Worked it out. But I wrote the addition, the fractions by addition. It actually was when I wrote it in common denominator over g, actually just d. It's going to be for, let's just say 5. Let's just say 5 is d and 7 is g. Merge them together, it's going to be g multiplied by the 2, and 7 is g, so cool. How you would do this algebraically. So let's just have an example here. Plus 9 over x squared over plus 6 over x. So one individually. So let's look at the 1 plus 9 over x squared. That means is x squared over x squared 9 over x squared. We have a look at that. What we can actually write now is squared plus 9 squared. You can factorize this term, so right down here, x minus, isn't it? My bad. Minus. So we can say minus 3. Okay, we're going to take, very messy, but bear with. I'm going to use that. So what is it? It is 2 plus over x. That it's basically 2x all over x, 6 over x. That is basically x plus all over x, using plus x. We have all that. I'm going to draw all of that over here, and bring it over here. So I have x plus minus 3 x squared. It's going to be all over plus 3 over x. You can write here. What you can write here is what you say is this denominator here. If you invert it, you can actually multiply these two together. You can say x plus 3 to hate things. 3 x squared. Write it lower. Do that. Have x minus 3 plus 3 over x squared multiplied by x all over 2. So look at this. Actually take out two terms that are similar. So have x plus 3 the numerator here, plus 3 here in the denominator. Do here is just cancel them out right now. So by and by. Anything else? No. So right in the end here is x minus 3 divided by 2x squared. And your answer. I'm sorry for being so messy. I just hate this screen right now. I wish I was using a whiteboard. Oh, edit this. This is just when I wrote it. Okay, anyways, keep going. Now what we're going to say now is binomial expansions. Is expanding your actually binomial expansions is basically the same as the Pascal's triangle. So actually write out, this is basically just be a rule where you don't need to write out the triangle. So just take this and here say is 2n 1 n minus 1 y1 2. It's going to be x minus 2 y2 plus blah 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 n and y to the n. These brackets represent is that n is your of rows on the Pascal's triangle that you're going to be using, or n represents the total power. The 0 represents the 0 basically represents your first step, or on top of the y, basically. So now you go down and down and down, and you can see how it changes until it gets to nn. And what this means is that it has reached its top power, and this is an n, not a h. It's an n. Is that y now has the n power. Okay. Finally, division. Oh, is this something to look at? Division. So, if you remember your long division rules, it's when you're dividing a number by a number that is 2 digits or more. So let's just have a look at this example. You can see that not to be divided by 19 to make a whole number. So 0 and 0. 10 cannot, so because 10 divided by 19 will give less than 1. So we just can't. So now we bring to 106 right now. So you can get your calculator out and you can just say 106 divided by 19. If you're doing it in your head, then obviously you're going to know that it is 5. 106, so 106, so what am I going to say? 19 does not perfectly go into 106 5 times. There is a remainder. What you do is take 19, divide by 5, that number, and you take that number away from the 106. So in this case, it's going to be 106 minus 95, going to be 11. 4 down. Now you check what is 114 divided by 19. It is going to be 6. And I can tell you that it is perfectly, but if you wanted to just check by your 19 by the 6, I just did on my calculator. It says 114, but this we finish it off. You approve that, but now we want to look at it. I was going to say mathematically. Everything is mathematical. Algebra. So take this example. So is 6x cubed 5x squared 10x plus divided by x minus 1. Okay, so what you do here in this case is the 2x and see, okay, how many times does it go into the 6x cubed? You can divide the 6x cubed by the 2x, get 3x squared. Multiply the 3x squared by the 2x again, cubed, and you multiply the 3x squared by this one, so it's going to be minus 3x squared. Now you just change the signs, minus plus, this will basically get 8x squared. Divide your 8x squared by the 2x to get 4x. By the 4x by the 2x again to get 8x squared, so we can 0. Apply the 4x by the minus 1 to get x lines. And you can see it cancels, and minus 10x plus 4x is minus 6x. You look at this and you say, okay, 6 divided by 2x is just going to be minus 3. Put that there. You have that answer up there, but we want to prove that it's correct. Bring your plus 3 down. What you're going to do is you're going to multiply the minus 3 by the 2x again. You're going to get minus 6x, and you multiply the minus 3 by the minus 1 to get plus 3. Change the signs, I get 0 because they cancel out. So that would be how you do that. And last, I'm finally done this video. So just to look back very quickly, I looked at Pascal's Triangle. This is basically how we can represent a binomial expansion in a quick manner. See here that this triangle will also never change in numbers. So let's just take row 3, 1, 2, 1 will always be the pattern. Row 6, 1, 5, 10, 10, 5, 1, that will always be the expression. That will always be what's represented. And yeah, that will always be the case. Then we went on to factorizing. There are 4 types. You have your highest common factor, where you find out what's common in each. You take it out, and you make one whole expression into 2 multiplying terms. Then we went through grouping. So it's where you have one big expression, and you can break it off into 2 small expressions where 2 terms have similar variables. You factorize them out by highest common factor, and you basically end up with 2 expressions multiplying together. Then you have your difference of 2 squares. Have 2 separate variables being paired. We find out 4x squared is similar to, so it's similar to bracket 2x squared, bracket squared, 5y bracket squared. Basically, them into 2 different expressions multiplying together. And because we had the minus sign, they had to be different signs in each. Quadratic trinomials, where the product of, if they add together to give the 13x, when applied fully, they can. So it has 2 expressions multiplying together. Difference of 2 cubes. As you find the highest common factor, them out, and so you have a squared plus b squared. And with that part, you use the difference of 2 squares. algebraic fractions by multiplication. Forget your simplify, factorize, and solve. Try factorize it before you merge them together and see if you can cancel out anything afterwards. Fractions. And this was a lot to write. So is you take each one apart and see if you can buy it, and then you factorize what you can, put it back in as its form, and with the denominator invert it and have them as multiplying fractions, and that brings it back to what we looked at before. But expansions, it's basically the Pascal's triangle without drawing the triangle, and how you write it is basically in this form here. Remember that. We looked at long division. You take a polynomial and you have that dividing by a binomial or whatever it is, binomial, and you go through your division. You multiply them out and you take them away and all that, and you should zero at the end. Don't, it's wrong. The next video we're going to do part 2 and go into theorem, or not another theorem, a theorem, and some simultaneous equations. Okay, so I will use them.